Okay, compound measures. Right, this is going to be a bit of a revision for us, really. And we're going to look at the three main compound measures we use, and just check out that we remember how to do it, and maybe have a look at just the slightly more tricky end of the questions as well, possibly. Okay, and we've got three compound measures we use, and they are for speed, for density, so that's how much stuff is in some material, how many sort of atoms are packed into a certain amount of space, and pressure. That's so if you've got, say, water coming out of a pipe, it's the sort of strength behind that water. You might have lots of water coming out, but it might be quite weak. It'd be the difference between being able to stop the flow with your thumb, or you can't even put your thumb on the end because the water's coming out so hard. And that quite often get the pressure one particularly usually gets confused between the amount coming out as well. So it doesn't need to be a lot of water coming out of that pipe, but it could just be under a really strong pressure, really strong force behind it. Okay, so first of all, let's think about what sort of units we've got for speed. And speed tends to be, we've got our really standard one, which is like meters per second. We usually write it like this with a little slash in between. It could be sometimes written ms to the -1, which means the same thing. Or we might have, say, kilometers per hour, which usually we put the slash and the h. Sometimes people write it as, kilometers kmph maybe, or miles per hour, which would be mph, or you could put m/h, although that'd be a bit confusing with the meters. We tend to stick to the metric ones though, so miles per hour doesn't come up so much anymore. Be kilometers per hour, meters per second, and so on. Density, so that's how much stuff in the amount of space. So generally that's going to be units of weight, usually for us, so that's going to be grams, and it could be grams per meter cubed, because it's got to be volume. It's the amount of 3D space. It could also be, say, grams per centimeter cubed, but it's always going to be something cubed. And then pressure, the force is usually in newtons, and then it's pressure per area. So newtons per centimeter squared, maybe not cubed. It's just going to be an area, flat area. So the flat face at the end of a tube, which is a circle, and how many newtons per that sort of space. We also have for pressure, a good old-fashioned common one we used to have was pounds per square inch. So that might be written something like that. Pounds always used to be lb/square inch, pounds per square inch. And you hear that one quite a lot still with things like pressure in sort of tires and so on. Right, so basically all of these speed things are the distance per a unit of speed, distance per speed, and that's exactly how we calculate it. Distance over time, distance per unit of time. And then density is the amount of stuff in the amount of space, so it's going to be mass divided by volume. At this point, it usually gets shouted at by scientists, because we kind of think of, in here, we're going to think of mass and weight as the same thing. They are clearly not the same thing, and any scientist would shout at me instantly for saying so. I'm not saying they are the same thing, but we can kind of think of it as that. So the mass is basically the weight for us. And then pressure, we've got force over area. It's force per the amount of area. Newtons per centimeter squared. Pounds per inch. Force per area. Okay, and you should hopefully remember our three triangles. We've got our speed, distance, time triangle. These help us work things out. And we've got speed in the bottom left. In fact, always with the speed, density, and pressure, speed, density, or pressure is always in the bottom left, and then you go round. So speed is density. Density is distance over time, so SDT. I always put a little line in to remind me that's a little divide line, and then the little x, which obviously means times. And then density, mass, volume. Density is mass over volume, and then pressure is force over area, force per area. Okay, right, so those are our three triangles: SDT, DMV, and PFA. And if you remember those, always start in the bottom left and move around clockwise. Let's put those little triangles up in the top right of the screen, and let's just try a couple of example questions. These shouldn't be too taxing for us. How long does it take to travel 125 kilometers at a speed of 50 kilometers per hour? Well, how long? What they mean by that is not the distance, is it? It's the amount of time. So there's my time. Now if I look at my triangle, if I covered up the time, I'd be left with d over s. So that means I've got d over s, distance divided by speed. So if I put my distance, which is 125 kilometers, divided by my speed of 50 kilometers per hour, and I get my trusty calculator out, even though I don't really need to, just to check that right, and it is 2.5. 2.5 what though? This is the tricky thing that some people find a bit hard, is what units am I going to use? Well, look at the question and just use the units for time that are already in the question. And the units for time I've got here are hours. So this is 2.5 hours. In fact, it's a good thing to remember. The units must match. I've got kilometers over here and I've got kilometers per hour. That means I can do my straightforward calculation. If one of these wasn't in, say, kilometers, if this was how many meters that is, then, which would be, you know, a lot, 12,000, no, 125,000, sorry, meters, I would have to convert it into kilometers because they must match. The units must match. Okay. Anyway, took them 2.5 hours. Just about as long as it takes me to explain the question. A body with a mass of 400 grams has a volume of 8 centimeters cubed. What is its density? So I've got the mass, I've got the volume, I want to know density. So I look at my triangle. If I want to know density, the other two units here are mass over volume, and that's exactly what density is. Density is mass divided by volume. My mass in this case is 400 grams, and my volume is 8 centimeters cubed. So I'm going to do 400 divided by the 8, which I'm pretty sure I know what that is, but I'm just going to check, and it's 50. And what are my units? Use the units in the questions. Look, this is grams over centimeter cubed. So those are my units, grams per centimeter cubed. 50 grams per centimeter cubed is my density. It's a compound measure, density, so it must have a compound unit. Okay. 2 more examples, then you'll be able to go off and do some questions on your own. Leona cycles 1.5 kilometers in 6 minutes. What's her average speed? And they're telling us what units they want us to use here, which is kilometers per hour. Now, because they're telling us that they want it in kilometers per hour, we must be working in kilometers per hour. So the first thing I'm going to need to do is change my minutes, because in my question I've got 6 minutes. I need to know that as hours. Right, minutes. Let's put that as actual minutes. Minutes. If I want that to be, sorry about the writing, I'm writing on this little graphics tab, which I'm useless at. And I want that to be hours. Well, if you were going from hours to minutes, well, we know that there are 60 minutes in an hour, so you'd have to times it by 60. If I was going from minutes to hours, I'm going to do the opposite. I'm going to divide it by 60. That makes sense, doesn't it? 60 minutes divided by 60 gives me 1 hour. So first of all, let's do that. Let's do 6 divided by 60 is, if you do it in a calculator, you will find that it is 0.1 hours. Okay, so I've changed my minutes to hours. Now I can do my speed calculation, which is speed is distance over time. My distance is 1.5. My time is 0.1 hours. And if I do that, I will get a speed of 15 kilometers per hour. So, you know, sometimes you need to convert these units. Always check that they're the same. If I'd just done 1.5 divided by 6, I'd have got completely the wrong answer. Right, last example. Philip drove 42 kilometers from Bath to Bristol at 72 kilometers per hour. Good old Philip. How many minutes did this take him? Okay, so let's show you what's going on here. I need to find out, firstly, time is what we're trying to work out. If I look at my triangle, cover up time, I'm left with distance over speed. So there's my basic calculation. Time is distance divided by speed, which in this case, it's a distance of 42 kilometers. It is a speed of 72 kilometers per hour. Now I'm going to just chuck that in my little calculator that I've got here. And I've got some absolutely horrific decimal answer, which I'm going to write the first bit of. 0.58, and then it's 3 recurring. I'll just put a little dot above that just to show that my answer is recurring. I don't need the little ellipsis there, the little 3 dots, but it just reminds me whilst I'm working out that it's not 0.583, it's 0.583 recurring, an infinite amount of 3s. Now I'm going to change that. I'm going to convert it to minutes. 583 recurring. Now to go from hours to minutes, I said I've got to times it by 60. So I'm going to times that by 60. Now this is the important bit. You need to, don't retype 0.583 in your calculator. Leave the answer you've got, 0.583 recurring. Use the answer button, press ANS, that's what it stands for, answer, and it uses the previous answer, times it by 60, and you find that actually, magically, all those horrible decimals have gone, and I've actually, in this case, got a nice whole number as an answer. Now, if I just done 0.583 and times that by 60, I wouldn't have got the right answer. Anyway, it is 35 minutes. Okay, so we had to convert it. Just watch out for those ones where either you might need to convert it before you calculate, or where you can convert it after you've calculated your speed or time or whatever it is. Okay, right. At this point, I want you to pause the video. I want you to quickly do those 4 questions, or slowly do those 4 questions. That's up to you, really. I don't care how fast you do them. Just as long as you pause the video, do the questions, and then you can unpause and see if it agrees with my answers. Okay, so pause. Yay, well done. We have paused, or you have done your answers, or you have just cheated and just let the video play, in which case, bad you. Bad you. I judge you. Harley cycles 24 kilometers in 1 hour 30 minutes. What is his average speed in kilometers per hour? Speed equals distance over time. My distance is 24 kilometers. I need the time in hours. It's 1 hour 30 minutes. That's 1.5 hours. Now, if you changed your 30 minutes into hours, you divided it by 60, you'd find it was 0.5, and then add the 2 things together. Either way, it's 1.5 hours. I know that, so I can just do it as it is. Right, 24 divided by 1.5 equals, are you ready for this? 16. Did you get it right? I hope you got it right. Kilometers per hour. Let's go over this side. I was going to go down there, but I'm not crazy. I'm going to go over here. A body has a density of 8 grams per centimeter cubed and a mass of 240. What is its volume? Well, let's look at our triangle. Mass, density, volume. If I cover up volume, I'm left with mass over density. So mass divided by density, which is, my mass is 8 grams per centimeter cubed. My, no, it's not, is it? What am I doing? That's my density. Let's scrub that out. Let's just scrub that. That never happened. Never happened. Thank goodness I never make mistakes in the classroom either. Right, my mass is 240 grams and my density is 8 grams per centimeter cubed. Look, my 2 units match, both in grams, so that's happy days. 240 divided by the 8 is 30. But what am I after? I'm after volume. What's the unit of volume in the question? It is this, centimeters cubed. So it's 30 centimeters cubed. Well done if you got that right. A force of 20 newtons acts, that means it happens, over an area of 2.5 centimeters. What is the pressure? Under pressure is force over area. That's what pressure is. That's what I can see up here, force over area. My force is 20 newtons. My area is 2.5 centimeters. So let's do it. 20 divided by 2.5. A bit more straightforward, this question. And it's 8. But what are my units? That's the tricky bit in this one. Well, we've got newtons on top. I've got centimeters underneath. Oh, centimeters. That should be centimeters squared. Sorry if that confused you. Someone's not typed up that question properly. Not me, obviously. But it's newtons per centimeter squared. Now, if you didn't notice, bad you should have noticed. See, I put these mistakes in deliberately just for you to spot them. Harry jogs at an average speed of 6 kilometers per hour. Yeah. For 45 minutes. Boo, because we don't want minutes. What distance does he jog? Right, we've got to change our minutes first of all. We're going to convert them. There's my minutes. I want to go to hours. There are 60 minutes in an hour, so divide it by 60. Do that in a calculator, you'll find that it is 3/4, otherwise known as 0.75 hours. Okay, so I've now changed that to hours, which means my 2 units match, and I can work it out. Distance. What is distance? Well, look up here. Distance, if I cover that up, I'm left with speed and time. They're next to each other, so it's speed times by time. My speed is 6. Wow, how fast. Times by my time of 0.75 hours. 6 times by 0.75 is 4.5. But what units? Well, it's distance, and the unit of distance in my question is up there. It's kilometers. So it must be 4.5 kilometers. Okay, well done. If you got it right. Not well done if you didn't. But it's fine, because look, I want you to pause again. I've got a couple of harder questions for you to do. What fun. Okay, so pause the video again. Make sure you read it properly, and good luck. Okay, so we have unpaused. Let's have a little quick read through the question. A sculptor, he's like an artist that works with 3D materials, needs to lift a piece of marble. It is a cuboid, so you know it looks like something like that, with dimensions of 1 meter by 0.5 meters by 0.2 meters. Marble has a density of whatever that is, 2,700 kilograms per meter cubed. The sculptor's lifting gear, so his lift can lift a maximum load of 300 kilograms. Can the lifting gear be used to lift the marble? Well, let's find out how much the marble weighs, which means we are trying to find the mass. Mass is density times by volume. Okay, but what is my volume? It doesn't tell me my volume, but that's fine, because I can work out my volume, because I know that the volume of a cuboid is length times by width times by the height. So 1 times by 0.5 times by 0.2 is 1/10. It is 0.1 meters cubed, right? Because they were all in meters, so happy days with that. So I can then work out my mass, which is the density of 2,700 times by my volume of 0.1, which equals 270 what though? What we're working out mass, so that's basically our weight as far as our question is concerned, which the units of weight in the question are kilograms. So this is 270 kilograms. So the answer is yes, it can lift it. Oops. Put an exclamation mark even though we don't need it. Yes, it can lift it. Tick. Smiley face. Right, last question then. 180 grams of copper is mixed with 105 grams of zinc to make an alloy. Right, an alloy is a material that's made of more than one, bit of stuff, thing, material, job, thing. Yeah, so copper and zinc together makes this new metal. It's a metal made of 2 other metals, right? So the density of copper is 9 grams per centimeter cubed, and the density of the zinc is 7 grams per centimeter cubed. What's the density of the alloy? I could just add 9 and 7, but that'd be pointless. That's not what we're talking about, because we've actually got more copper than we have zinc. So the thing to do first of all is to work out, how much mass we've got, or not mass, sorry, how much volume we've got from the copper, how much volume we've got from the zinc, put those together to then work out what the density of the alloy is. Because I've already got the total mass, because I just add together the masses of the 2 metals, which is 285 grams. Okay, what I need to know now is what is the volume Let's put V1. Let's do the volume of the copper. Now volume is mass divided by the density. So that's 180 divided by the density of 9, which I already know what that is, but I'm going to check it on my calculator anyway, which is 20. And we're working in centimeters cubed here, so that's 20 centimeters cubed. And let's work out the volume of the zinc, so that's V2. So we've got 105 grams in this case, and a slightly lower density of 7. So 105 divided by the 7 is 15 centimeters cubed. Okay, so now we can work out the total volume. So 20 plus the 15 is 35 centimeters cubed. So now we want the final density of this alloy. So we need density is mass over volume. So there we go, M over V. Our total mass is 285 for the alloy, and its total volume for the alloy is 35. So we'll do 285 divided by 35 is, according to this, and I'm going to do it to, it doesn't give me an accuracy to work to, so I'm going to do to 2 decimal places, 8.14. If you did 1 decimal place, that's fine, or if you just write the whole thing down as well, that's also fine. As long as you've got to 2 decimal places, 8.14 grams per centimeter cubed. Okay, well done. What I would like you to do last then is to go to this link. Now, the link should be in the Show My Homework post, but in case you've lost it, then you could always type this tiny URL into the address bar, and then that will take you to this place, hopefully. And it gives you, there are 6 questions. Sometimes there's more than one question on a page. Some are trickier than others, and you work out whatever you think the answer is. Now, it is exactly the same questions as this, so I'm not going to work it out. But if I did work it out and I got the answer of, I think that they're doing 2,000 miles per hour, you put 2,000 miles per hour there, and then you obviously press the mark it button, and it will tell you whether you're correct or not, okay? And then at the end of it, it tells you what you got right. There's also some extra help videos at the end if you want to do it, or want to practice it. And it also gives you the chance of different questions if you want to repeat anything, okay? Right, well done. Good luck. I hope it goes well.